let us talk about the drag force. Now, sometimes we call this also the viscous force. And in a more colloquial way, we can call this the friction of fluid. So, well, when we say friction of fluid, okay, basically we're trying to say that this is a force that opposes motion, okay? And this is a force that is unique to fluids, which means gases and liquids. So if you move in a fluid medium, like water or air or something else, okay, you will find that your motion is being opposed. However, we should understand that drag and friction are indeed quite different. Now, first of all, there is a quantitative way to think of drag or viscous force, okay, and that is that the drag force Fd is equal to kV, or in some cases it is equal to kV squared. We don't have to know which one to use. They will usually tell us if they want us to use it. But what this means is that as your speed increases, so does your drag force. And that is one key difference between drag and friction. Friction is usually constant and independent of the speed, but for drag, it is absolutely dependent on how fast you move. The other thing that is quite interesting about this is that if your V is 0, in other words, your object is at rest, then there's no drag. However, friction can act on stationary objects, as we have seen in the case of static friction. Right? So basically, to keep things simple, if this is my object, I'm trying to move in a body of water. Okay, if I move this way, then of course the drag will act this way. Okay, and this drag is directly proportional to your speed or the square of your speed. Okay, drag will always oppose your motion. Okay, and it's like we said, proportional to speed or v squared.